4:30. So we're going to try and go through this. All right, we're going to move just a little teeny bit quicker. Right? Is that okay?
What you said, sir?
I said that I have a C6 session at 4:30. So we're going to move a little bit quicker to go through this one. All right. All right, because we have 40 minutes, we have roughly 45 minutes. I'd love 10 minutes to eat. So we want to finish by 4:20 to 4:25. So let me just clear all of this because the white page is finished. But module 3, we can run through really easy, man. All right, there's just a couple of things that it's going to be a little more hectic, but easy stuff. And then remember, what's your homework? Your homework is 2009. All right, and do it on that time. Do it on that time. All right, meaning set 2.5 hours. Now, Marika, listen what I want you to do. When the 2.5 hours done, look where you finish, but don't stop. Continue the paper and finish it. All right, but at least I know, say, oh, this is where the time would have run out in a real test. All right, so I want you to finish the full 2009 paper for Unit 1 and Unit 2. Then I mark it. All right, so let's look at this now. So reach Module 3 Calculus, easy. It says, Marika, use L'Hopital rule to obtain the limit as x approaches 0 of sine 4x over sine 5x. So them actually said to use L'Hopital rule. So I want to find the limit as x approaches 0 of sine 4x over sine 5x. Using L'Hopital rule, we know we're going to have to differentiate the numerator and differentiate the denominator. So this will be equal to the limit as x approaches 0 of differentiating the numerator. When we differentiate sine, we get cos, so we get 4 cos 4x. Then we'll differentiate the denominator, we're going to get 5 cos 4x. Now you can apply cos as 0, apply the x as 0, so you're going to get 4 times the cos of 0, and the cos of 0 is 1 over 5 times the cos of 0. The cos of 0 is 1, so I end up get 4 over 5. That's the limit, 4 over 5. First spot, cool, right? Nothing strange with that one. 4 over 5, right, Marika?
Yes, sir.
All right, 4 over 5, good. Now, the next one now, Marika, it says, y is x over 1 minus 4x. Find dy by dx. So y is equal to x over 1 minus 4x. And we need to find dy by dx. All right, I'm just going to reduce the font size. I don't like it. How do I reduce the font size? What did I do to make the font size increase? Oh, I see. This should have bring it down now. Yeah. So y is equal to 1 or x over 1 minus 4x. So now, Marika, what we're going to do to differentiate it is use product rule. Part 1, part 2. So we're going to use product rule, or you can use quotient rule, depending on your choice. Let's use quotient rule then. So dy by dx is, you start with the bottom. It's going to be 1 minus 4x multiplied by the derivative of the top, which is 1, minus the top, which is x, times the derivative of the bottom, which is negative 4, over the bottom square, which is 1 minus 4x all square. So that would be dy by dx. Nice. So dy by dx works out to be simplifying the numerator. 1 times 1 is 1 minus 4x. Then this is minus 4x, it will become plus 4x. And that is over 1 minus 4x all square. So as you can see, Marika, the 1 minus 4x plus 4x, the minus 4x and the plus 4x cancel. So this become 1 over 1 minus 4x all square. Yeah, cool with this? That's dy by dx, right?
Yes, sir.
Nice, so we're done with that now. That's dy by dx. Can tell them, say dy by dx was 1 over 1 minus 4x all square. Then now it says, show that x squared times dy by dx is y squared. So now, Marika, we're going to start just to write down back what y was. Y, remember, was x over 1 minus 4x. Then now, in a different color, we're going to write down what dy by dx is. Dy by dx, we just found was 1 over 1 minus 4x all square. So Marika, if we multiply dy by dx by x squared, if we multiply both sides by x squared, we're going to end up get x squared times dy by dx. That would ended up be equal to, if you multiply this side by x squared, you get x squared over 1 minus 4x all square. But Marika, all of this can be written as x over 1 minus 4x all square. Oh, is this all square? Yeah, not true? Not true, right?
Yes, sir.
And so therefore, x squared dy by dx is y squared. So that's the proof. X squared dy by dx. I know I'm writing lean. X squared dy by dx. End up saying this is equal to y squared. So now no worries at all. We're nice. That nice. All right, we're cool. So that part done. All right, so that's done. Nice. Now it says hence. This is where implicit come in place, Marika. Implicit differentiation. Hence, show this equation down here. X squared d2y by dx squared plus 2 times x minus y times dy by dx equals 0. Let's sip some water as I look at it. Look at this question. All right, I see it already. All right, so we can take it on now. So it is indeed implicit, Marika. So what we're gonna do is use the implicit differentiation. We're differentiating this, Marika. That's what we're doing. We're using implicit. So we know how it go already. We keep the first, then we differentiate the second. Differentiating the second, you're gonna get d2y by dx squared. Then you get plus, keep the second, which is dy by dx. Then you multiply it by the derivative of the first. When you differentiate the first, you get 2x. And then that is going to be equal to, when you differentiate y squared doing implicit differentiation, you get 2y, where you always multiply it back by dy by dx. Yeah? Cool at this line?
Yes, sir.
So then now, Marika, we just need to bring over this to make it equal 0, because there was an equal 0 over that side. So that's all. Bring over that part there. So writing this back now, we get x squared d2y by dx squared. Then we have plus 2x dy by dx minus 2y dy by dx equals 0. So clearly, Marika will say that it have 2 in common. So we can factor out the 2 and dy by dx. and write it as x squared d2y by dx squared. Factoring out the 2, we end up get plus. Factor out the 2, we're going to get 2 times. Factor also dy by dx, and you'd be left back with 2 times x minus y, close the bracket, times dy by dx equals 0. That's it. We're done. Soft. It's soft, don't it? Right? All right. Cool. So that's that there, Marika. And we're done. Now let's look at part 3 now. Part 3, Marika says, a rectangular box. Now, Marika, anytime them say box and them say rectangle, I always like to just picture something while going, right? So before I even do the question, I just start think of one box. So I'm just gonna draw my box. And them say rectangular, right? So I'm just trying to draw a rectangular box. This is the box right here. It's my rectangular box that they're giving me. Boom. So good, we have a box. All right. I know it don't look exactly like a box, but bear with me. I'm not an artist, not as good as you are, but we're doing here to do math. So it says a rectangular box without a lid is made from a thin cardboard. The sides of the base are 2x and 3x, and its height is h. 2x, 3x, and h. 2x, 3x, and h, right? And then tell Marika say, let me see what else them tell we. Them tell we so the total surface area is 200. Show that h is this. So Marika, them tell us that the total area of the box, total surface area is 200. Now Marika, remember, the top of the box don't have the box open. So that means we now find up here, so this area up here, so nothing include, because the box, that part they open, right? So now go find the top area. So Marika, this is how we find total surface area. Total surface area, remember this formula now, you know. Total surface area is equal to perimeter of the end, perimeter of the end, perimeter of the base, times the length of the whatever is given, whether pyramid or whatever. It's perimeter times length plus 2 times the end area. 2 times the end area, Marika, is the area at the bottom plus the area at the top. But in this case, we don't want the area at the top, so minus A. So minus the area at the top. We don't need the area at the top, Marika. We don't need it. We literally don't need it. Because it open. We minus A because it is open. Because it is open. So since it is open, now we may go ahead and find the total surface area. Then tell us that 200 is the total surface area, and that's the perimeter of the base, Marika. So the base here, you find in the perimeter of the base, you have 2x. Well, 2x is not right there. You have 2x, 2x, 3x, and 3x. So the perimeter of the base is 6x, 8x, 10x. Perimeter of the base is 10x times the length, which is the height, h. So it's 10xh plus 2a minus a is just a, which is the area of the base. The area of this base, Marika, would just be 2x times 3x is 6x squared. So 200 is equal to 10xh plus 6x squared. Don't need to make h the subject. So I'm going to bring over that now to end up at 200 minus 6x squared is equal to 10xh. Then now, since I need h to be the subject, Marika, I'm going to divide every side by 10x. Divide this by 10x. Divide this by 10x. Divide this by 10x. And then now, I know that this 0 cancel this. So I get 20 over x. 20 over x. And then I get 6 over 10 is 3. So I get minus 3 over 5. Then x squared over x leave just x. So I get 20x. 20 over x minus 3x over 5. 10x cancel 10x. That equal h. That's it. Cool it is, Marika?
Yes,
Cool?
sir.
Nice. So that's that. This is a C-set question. Come on. Nice. So that's it. I'll prove it. So that's the first part. C-set maths. Nice. Now it says find the height of the box for which the volume is maximum. Now to find the height of the box for which the volume is maximum, first we need to find the volume formula. So first thing, Marika, we have to remember that to find the volume of the box is equal to, volume is base, well, not base, let me use length times width times height. That's volume, right? Length times width times height, no? That's volume. Length times width times height. So in this case, volume is 3x times 2x times h. So volume is equal to 3x times 2x times h. Right, Marika? That's volume though, right?
Yes, sir.
So this is equal to 6x squared h, but we already know what h is. H is 20 over x minus 3x over 5. So all we need to do is plug that in right there. So the volume formula, Marika, is 6x squared, and that is multiplied by 20 over x minus 3x over 5. This is the volume formula. And finally, we're going to simplify it. So volume works out to be this x cancel out the x from here. That is 120. X squared over x is x, so 120. X minus 6 over 6 times 3 is 18, so that's 18 x cubed over 5. This is the volume formula. This is the volume. Now, what are we trying to find again? I think where the volume is maximum. Find the height of the box when the volume is maximum. So we need to find the volume max. So we need to find V max, but Marika, at a maximum point, we know that its derivative is 0. So at max volume, Marika, we know that dV by dx equals 0. dV by dx equals 0, yeah. Yeah, man. So now all we need to do is differentiate that formula right there. So dV by dx is going to be equal to, when you differentiate 120x, you get 120 minus, when we differentiate 18 over 5 x cubed, carry down the power, 18 times 3 is 54 over 5, subtract 1 from the power, x squared. That's dV by dx, and this is equal to 0. Solving this equals 0, we can multiply through by 5. 5 times 120 is 600. So we get 600 minus 54x squared equals 0. We bring over 54 over here to get 54 x squared equals 600. And so, Marika, to get x now, we divide through by 54. I'll divide through by 54. So that will give us x squared. Put that in our calculator because I'm too lazy. 600 over 54. That is 100 over 9. That is 100 over 9. So we get x squared equal 100 over 9. And so, Marika, we can find x by square rooting both sides. So x equal to square root of 100 is 10, square root of 9 is 3. X equal 20 over 3. So that is the value of x when v is maximum. And so, Marika, h max then. So the h max, we can plug in the value for x in the formula for h. Remember, this is h. So the height at which the volume is maximum is 20 divided by that x value of 10 over 3 minus 3 times that x value of 10 over 3, and we divide that by 5. Cool it that, Marika? You cool it that question?
Yes, sir.
All right, so let's finish that off now. So, all right, so what we end up getting now is this is going to work out to be, all right, just plugging it in that formula where x is, that is going to be 20 divided by 20 divided by x, and x is 10 over 3. Was it 10 over 3 or 3 over 10? Yeah, 10 over 3 minus 3 times x x is 10 over 3, and we divide that by 5. So we get 4. Look how it worked out easy, Marika. Find the height for which the box has its maximum value. The height is 4 centimeters. In this case, h equal 4 centimeters. You don't love maths, Marika, when it answer work out so easy. Don't, it just make you feel calm, don't it?
Yes, sir.
Yeah, like I said, whoa, that's just 4 centimeters. Makes sense. That's the height at which the box would be maximum. Easy. So that's how we apply differentiation to these questions. All right, nice. Moving right along, we can run through this question. Like literally, Marika, we're gonna run through this question. Look at this. It says, use the substitution u equal 3x squared plus 1 to find this integral. So let's do that quickly. So we're finding, I like to call my integrals I. You know that already. I is equal to the integral of x over 3x squared plus 1. X over the square root of 3x squared plus 1 dx. This is what we have for I. So therefore, Marika, we know that we can do a u substitute. They said substitute u as 3x squared plus 1. So now, if that is u, you can write down your du. Du is going to be 6x dx. Now, Marika, you know what we always have to do. We always have to generate that 6x dx there. So we're going to put a 6 right here and put a 1 over 6 on the outside. Right? Because this 6 cancels this 6. So that generates our du. This part right here is our du. This is our du. So now we can end up right that I is equal to 1 over 6 times the integral of this 6x dx is our du. So that becomes 1 du, because this is 1 du, over the square root of 3x squared plus 1. 3x squared plus 1 is u. So that becomes 1 over the square root of u. Now we can easily integrate this to get 1 over 6 times the integral of the square root of u in the denominator is u to the negative half. And so all we have to do now is add 1 to the power and divide by the power. So it becomes 1 over 6 times, in bracket, add 1 to the power. It becomes u to the half, divide by the power. of 1 over 2. And then we have plus our constant plus c. Right, Marika?
Yes,
Yeah?
sir.
But then we know, so we can't leave it like that. We have to, of course, rewrite it back as, you see this 1 over a half right here? 1 over a half is 2. 2 over 6 would make it become 1 over 3 times the square root of u plus c. But they gave you the answer in terms of x. So that means it works out to be 1 over 3 times the square root of 3x squared plus 1 plus a constant c. It's that easy. All right? Nice. So that's that right there. Easy. Like literally easy 6 marks. That's equal to, we end up get with 1 over 3 times the square root of 3x squared plus 1. Nice. Now let's attack this easy 4 marks that they're giving away. They say a curve passes through the point 3 minus 1, and it tells us that it have this gradient, find y. Now you realize them love asks with this, like unit 1 asks with this, unit 2 asks with this. Them telling you that the gradient, Marika, dy by dx, that's what they're giving you. They tell you that the gradient function dy by dx is, see the x squared minus 4x plus 3. That's dy by dx. X squared minus 4x plus 3. So if this is dy by dx, Marika, to find y, we just need to integrate dy by dx. So y is the integral of x squared minus 4x plus 3. That's it. We just integrate this to get y. So let's go ahead and integrate. Integrating that, what we're going to get is x cubed over 3 minus, this going to become, add 1 to the power 4x squared, divide by the power of 2, plus, it's going to become 3x plus our constant k. So now what happens is, Marika, this end up now becoming, remember, we need to find k, but they give you the point 3 minus 1. So you're going to plug in x as 3 and y as minus 1. Plug in x as 3 and y as minus 1. So at 3, 1, or at 3 minus 1, we'll plug in y as minus 1, we get minus 1 is equal to 3 cubed over 3 minus 4 times in bracket. This is now 3 squared over 2 plus 3 times 3 plus k. Working out what all of this number is going to be, we're going to get minus 1 equal. 3 cubed is 27. 27 over 3 is 9. Then 3 squared is 9. 9 times 4 is 36. 36 over 2 is minus 18. Then we have plus 9 plus k. But Marika, 9 and 9 is 18. 18 minus 18 is 0. So that means k equal negative 1. So that implies k equal minus 1. Since k is equal to negative 1, we can end up give them the equation of our curve now. That means our curve is y is equal to x cubed over 3 minus 4 over 2 is really 2x squared. So that's minus 2x squared plus 3x minus 1. All right, and that's that right there. We're done. Nice, easy, soft. We're done with that. So that's that part. Nice. So this done, this done. Part C now, Marika. Part C look nice here. Let's see what they say. the figure below shows part of the line y equal 2x plus 5 and part of the curve y equal x minus 4x. It tells us that the line meets OY at B and the curve at OX at C. Find the coordinates of A, B, and C. Oh, easy stuff, man. I thought it was nice, but it's boring. Look at this, Marika. You have a straight line and you have a curve. The line I'm going to intersect the curve at A. C is the root on the curve, and B is the y-axis intercept of this line. So we can even just do that right here. So let's do it right here in this little space right here. So know that B is the y-axis intercept, and on the y-axis intercept we know x equals 0. So in the line, Marika, y plus 2x, it's going to be y plus 2 times 0 equal 5. And so that means B is the point where x is 0, but y is 5. Cool it that? That is B. Cool it is, right?
Yes,
Right,
sir.
Marika? Now we need to find, let's find C first. C is the y-axis. C is the root of the curve. So C is the root of the curve. So Marika, if C is the root of the curve, what you're gonna get is y, which is equal to y0 on the curve at C, so you have 0, is x times 4 minus x. So in that case, we're gonna get x equals 0 or x equals 4. But it can't be 0, Marika, it has to be 4. So in that case, C is the point 4, 0. It can't be the one where x is 0, because x is 0 and y 0 is right here. That would be the origin. So it have to be C is 4, 0. Does that make sense? Make sense? Yeah?
Yes, sir.
Now we need to find where both of them intersect. So we need to solve it simultaneously now. So A is where the line and the curve meet. So let's do that on the whiteboard. So A is the point where the line and the curve meet. All right, so remember that the curve is y equal to x times 4 minus x. And then the line that they give us is y plus 2x equal 5. Y plus 2x equal 5. So from this, Marika, what we can do now is we can make y the subject from this one to get y is 5 minus 2x. All right, so we have 10 minutes to wrap up. We're gonna finish, don't worry. Y is 5 minus 2x. We plug it in here. So we're gonna have 5 minus 2x, Marika, is equal to x times 4 minus x. All right, and so what happens then is when we subtract them, we expand, we get 4x minus x squared, and that's equal to 5 minus 2x. And so, Marika, what we need to do now is bring over the x squared over here to get x squared, bring over the 4x over here to get minus 6x plus 5 equals 0. Signs are the same, both of them positive. So we factorize. By factorizing, we're going to get 5 and 1. We're going to have signs are the same, both of them negative. So that's minus and minus. So we have the x here and the x here, and this equals 0. So what we end up get, Marika, is x equal 1 or x equal 5. Yeah. Cool with this? Now, when x equal 1, Marika, let's see. When x is 1, you get 1 times 4 minus 1. So the y value would be x is 1, 5 minus 2 is 3. So A is the point 1, 3. They might say, sir, why did that show the 5? Come on, we had to throw away the 5. the 5 couldn't be valid. Because if this is when x is 4, the 5 would be somewhere down here. So that's a different point. What that means is the line and the curve intersect somewhere else. If you were to continue the line like this and continue the curve like this, the curve and the line gonna meet 5 somewhere else down here. So you get what I'm saying? Right, Marika?
Yes, sir.
So we don't want that part there now. So that's it. So now we're good. All right, so that's that. So A is the point. A is the point 1, 3. All right, nice. So now it says, hence, find the exact area shaded. So to find the area shaded, Marika, we know we have to do integration. So we need to do integration to find the area shaded. All right, so to find this area, we're gonna do quite a little bit of integration. Let's see how we can break it up. It's not so straightforward. Now let's see, this is the line. If we integrate the line from 0 to 1, that would give us all of this area. Integrating the line from 0 to 1 would give us all of this area. Then if we integrate the curve from 1 to this point, that gives us the rest of this area. But why is it 9 marks? That's easy. That's crazy. They're giving us 9 marks for nothing. All right, so this is what we're gonna do, Marika. All right, so the area, we can write it even right here. The area is gonna be equal to the integral under the line. So it's equal to AL, meaning the area under the line, plus AC, meaning area under the curve. So the final area, Marika, is equal to the integral from area under the line. We integrate from 0 to 1 of the line, and the line, remember, had equation. What was the equation of the line? Let me look at the whiteboard. 5 minus 2x. So let me just finish it off here. So the final area A is equal to area under the line plus area under the curve. And the area under the line that we want, Marika, is the area under the x coordinates being considered, which is from 0 to 1 for the line, which is 5 minus 2x dx plus the area under the curve, Marika. The area under the curve is we're integrating from 1 to the next x value being 4. Stop at 4, Marika. We stop at 4 because we only want up to 4. We want all of this. So when we do that now, Marika, what we're gonna get, integrating the curve, which is 4x minus x squared dx. We're gonna do our integration now. So doing our integration now, we're gonna end up get that when we integrate this, we get 5x minus, this becomes 2x squared over 2, and we're integrating from 0 to 1, plus integrating over here become 4x squared over 2, then we have minus x cubed over 3, and over here we're integrating from 1 to 4. Now I know you're not used to seeing the line, so let me put the box. All right, this is probably more familiar. So when we integrate, we put in the 1, we're gonna get that the area is putting in 1, 5 times 1 is 5, minus, putting in the 1 in here, this 2 would cancel this 2, 1 in here would become 5 minus 1, we don't need to put in 0, then we have plus. Over by this side now, we'll plug in the 4, 4 squared is 16, 16 times 4 is 64, 64 over 2 is 32, minus, putting in the 4 here, 4 cubed is 64 over 3, close that bracket, minus, we'll put in 1 now, 4 over 2 is 2, minus, we'll put 1 in here, we have 1 over 3. So So this is what we need to simplify. Now we're not going to use a calculator. We're going to do it normally. 5 minus 1 is 4, plus 32 can be written as 96 over 3. So that's 96 minus 64 all over 3. And then this is now minus, this becomes 2 can be written as 6 over 3. Yes, 6 over 3. So it becomes minus in bracket 6 minus 1 over 3. By the way, Marika, just put it in a calculator. Don't stress yourself. Let's finish it off right here. So the area is equal to 4 is 12 over 3. All right, so 96 minus 64 is 32. So that is plus 32 over 3. And then this right here, 6 minus 1 is 5. So that is minus 5 over 3. Then you can actually find the area now. So the area is 12 plus 32 is 44. 44 minus 5 is 39. 39 over 3. 39 over 3 is 13 units square. Marika, imagine it work out so easy, don't 13 units square. Answer work out pretty, don't? Yeah? Right, Marika?
Yes, sir.
Nice. All right, so we're going to stop here. All right, we'll finish this paper. All right, so what I'm going to do is, well, I'm not going to have to upload over about this. Remember, your homework is 2009, Unit 1 and Unit 2. Feel free to submit it whenever, and I will upload the solution for the mock exam, paper 1, the full thing, by later tonight. Not right away, because you don't have another class now. So you're going to get that soon, all right? All right, Marika, so take care, all right?
Yes, sir. Take care as well.
All right, and how did you find this paper? Challenging, easy?
Too bad.
Wasn't bad.
It's just the, I guess, the time and the spending on some of the questions.
Yeah. All right.
Yes.
Take care, Marika.
Yes, also. Bye.